This thing over here, this washing machine, is my Sony MCI JH-24 tape machine. And it's time to do some maintenance on it, in particular on the audio path. So let's get started. Now, I bought this machine in January in supreme condition. There was one small issue with it. It had a little bit of flutter on the audio, a bit too much to my liking. Like every tape machine has some flutter somewhere, but a little bit too much. The way I fixed this was by, well, first knocking a bit on the torque board. These machines have very brittle connectors on it, so if you wobble them a little bit, they get connection again. And I adjusted the torque on both of the motors so that I had enough tension, and I repositioned the dancer arm because the dancer arm was really misaligned. And by doing all those steps, the machine is now very low on flutter. I cannot really measure it, but I can listen, and right now I can accurately reproduce it and use it in productions without a piano sounding off key or something. So really cool. But the next thing that I need to do, that I want to do, and I also are going to need to do regularly, is aligning the audio path for every single channel. Now, it's not that it's misaligned, and I really like how it's sounding right now, but the problem is that every channel now has its own sound. If you're working with mono channels, this is not a problem, but I also need to bounce stereo files through it, and it's really difficult to find two matching channels. And this is mostly from an EQing point of view. Like machines like these have a low and a high EQ band on it, which you use to pull everything together. But I really need to align it. And the reason why it took me a little bit longer is because I needed an alignment tape, which I magically found in the dungeons over here. This is a 24-track alignment tape. It's a 200 nano Weber full track alignment tape for 15 inches per second, which is also the speed that I'm using the machine the most on. But there's a small issue with this alignment tape. This is how it looks. It's not a lot of tape on it. There is a small issue with it, and that is that this tape is suffering from the sticky tape shed syndrome. Now, what this is, if I understand it correctly, is that the glue that they used to glue the magnetic material on the tape is attracting water, so it's getting a little bit wet and a little bit smushy. And what that results in is that it's going to stick to all the parts of the tape machine, would quickly clog up the tape machine. And when I put the tape like this on the tape machine and rewind it for 20 seconds or something, I think the motors will already stop spooling because of the junk that is on everything. And then I need to clean the whole machine with alcohol and stuff. And yeah. Now, luckily there's a solution for that. What you need to do when you have sticky tape is you need to bake it in an oven. And you need to bake it at around between 50 and 60 degrees. There's a lot of documentation on this, also on exact temperatures. I've already tried baking tapes myself. What I've experienced is that the temperature is not the most important part. It's the length at which you're baking it. You really need to bake a tape for like 8 hours or something, like a 2-inch tape. Leave it in the oven for 8 hours. Now, I'm using my own solution for baking a tape, which is a food dehydrator. Which I modified a bit so that I can fit a tape in there. And the issue that I have with it right now is that there's an electric motor in there, and it's of course an electric heating element. And if you think about that, that's magnetic. Like the electric motor, the fan, it's magnetic, and the heating element, it's magnetic. So if I'm baking tapes to use on the machine, it doesn't really matter that the contents on it are getting destroyed because I'm constantly overriding them. If I'm baking a calibration tape, which would easily cost more than 1,000 euros to buy new, like a good one, I don't want to get the contents destroyed. So I've come up with an idea to find out if my oven, my tape baking solution, is going to destroy the contents on the tape or not. So I have a tape on here. I'm going to rewind it, and then I'm going to output sine waves to all of the channels. I think a 1K sine wave, record it from the beginning till the end on the machine, and then bake this tape again in the oven for like 8 hours or something, and then play it back and see if there's still the sine wave on it or something else as well. And if there's something else on it as well, I need to find a different solution to bake my calibration tape. So that's what I'm going to do right now. And here you can see kind of my issue. I'm right now playing back a 1 kHz tone, recording it onto the tape, and we're looking here at the playback head. And we see, well, a lot of different levels here, like 9 and 10 for instance. And yeah, this is also not correct. And I have no clue what these two are doing. I do have sometimes a bit of issues with channel 1 with a kick on it. Maybe I destroyed it with a kick. Channel 2, I've never seen this in audio while using it. So maybe it's doing this with the sine wave on it, but not really obvious in audio or something. So yeah, here channel 24 is all the way in the corner while 23 is at +1. It's kind of like all over the place, and I want to get this, you know, straightened out from a level and a tone point of view. So yeah, but let's record this tape with just 1 kHz on it all the way, bake it, and see what happens. And there it is. It's the tape is in here, and it's baking in my special repurposed food dehydrator tape baking oven. So yeah, let's leave it in there for a while and see if the tones are still on there. All right, so let's see if the tape that I have freshly baked now still has those beep tones on it, and doesn't have any interference on it from the oven. Because if it has, then I'm not going to bake my precious calibration tape, of course. Oh, this looks good already. Also, what would be interesting, I did have some time to think about those first 2 channels. It could also be that it's one of the tape heads, but that would become clearer when we've got a calibration tape on there, because then we know if it's a playback head issue or a record head issue. Okay, we're in playback now, as far as I know, and there are my beep tones. Oh, it looks a little bit weird. Let's enable the audio. That's a lot of channels all at once. My master bus is clipping. In general, the beep tones are still there. So there are some issues with the machine, of course, but now I at least have a better overview of what is going on. But yeah, the beep tones are clean. Let's wind it a bit more forward. Higher torque, please. Yeah, still intact. Anyway, I was a bit afraid of like getting some low frequency interference from the coils in the oven. Yeah, still fine. All right, then I'm going to quickly bake my, or well, quickly, baking takes about 8 hours. I'm going to bake my calibration tape. We can start the calibration process. And I have baked the calibration tape now, and look. It is running, it's not smearing, it's not leaving any residue behind on the machine, so I can now use it to calibrate the machine. So first of all, what I already did in the, you know, a little bit in between when I was working, was calibrating the audio path, so that's the input and output and the VU meters. This is very important to have this calibrated correctly, because we are needing the audio in and out and the VU meters to calibrate it further. So now we've got the tape on here, and it's now time to calibrate the repro side of the machine. Repro stands for reproduction, so we're going to calibrate the level of the playback head and the playback electronics. We're going to do that for all 24 channels. Now the tape that I'm using is a 200 nanoweber tape. Now I'm not fully schooled into these Weber things, magnetism things, but I got a tip from a technician that I really trust, and he saw my initial video about the tape machine, and he said it can sound way better if you calibrate it at 520 nanoweber. Now I have a 200 nanoweber calibration tape, so how you do that is by lowering the volume. So I have to keep -6 decibels on the VU meters as my reference point when leveling. Now this is a little bit shit, because on the VU meters we've got -5 and -7, and -6 is like a small bar in between. But we have to pull the levels on all the channels towards there. So let's get started. And the way we're doing this is with a small screwdriver, flathead screwdriver. I'm only going to calibrate the low speed on the machine because that's the only speed that I'm using. I'm not using the high speed. And I also don't have a high speed tape to do this with. All right, so there it is. Oh, it's at -3 right now, so we can draw it back a lot actually. Oh, there we go. Minus. Beautiful. Next one. -6. Next one. -6. Alright, so I've got the whole machine now on -6 on the 1 kHz tone that's on the tape. The next step is calibrating the high shelf. So all these machines have equalizing in them. They have a high shelf and a low shelf. And this is to flatten the frequency response over the whole machine. I'm not sure yet when I want to have the high frequencies on. I'm pretty satisfied with the balance of the machine as it is right now. And I just saw on the calibration tape that the high frequencies are around -10 to -8, while the rest of the volume is at -6. So that would mean that it's shelving off a little bit high. But I do not have that feeling while using the machine. So I might calibrate it to -9 or -8 right now. And then later on, with a bit of material on the machine, with a bit of, music on the machine, I can judge better if I want it like this, or maybe have a little bit more high on the reproduction side. For now, it is important to at least have everything solid. So most of all, that all the channel pairs have the same equalization. So that's what I'm going to do now, like quickly. Alright, so if I did it correctly, then all the high frequencies are also like calibrated right now. If you looked closely on those reproduction cards, there's also a low frequency calibration, which is for 100 Hz. That's not on this calibration tape, so I'm not sure how I'm going to tackle that. In the end, it matters that channel pairs get the correct amount of distortion on both sides, and also the correct amount of low frequencies on both sides. So I might be able to do it later on, although this will be a lot of guessing. So for now, I'm not touching those settings. So what I'm now going to do is I'm going to put a fresh tape on it, or well, it's not really fresh, but like a clean tape on it. And I am going to rewind it and put the machine to record, and then calibrate the recording head using some sine waves coming from Reaper through the converters. And then of course listening to the playback head, because we've just calibrated that. So let's see what that'll do. And the first step of this record head calibration is actually the bias setting. Explaining tape bias is a bit difficult. I tried it the last time. I got a lot of comments from people saying, nope, that's not tape bias, that's tube bias. I was a bit confused because big tape machines is a new thing for me as well. What tape bias is, it's kind of like a tone that is being recorded onto the tape in order to keep the level straight or something, like a high frequency tone or something. Anyway, it doesn't really matter. But with bias, you actually make the tone of the tape machine, or influences the tone of the tape machine a lot. So by over biasing or under biasing, you can get more or less harmonics and that kind of stuff. Recommended bias setting for the tape that I have Quantity G456 tape on it right now. Yeah, Quantity G456 tape on it. Recommended setting is between 3 and 4.5 decibels. which I'm going to set it to right now. I am planning on later on experimenting a bit with the bias settings of the machine, of course. Most of all when using like real material, not with tones. But for now, let's first get this machine like up to its standards and experiment from there. I'm a big fan of doing that, like first get it to function properly. How bias works is actually pretty interesting. When you have the bias screw and you turn it up, you'll see the VU meter go like this. And then all of a sudden you keep turning up the screw, but the VU meter is going back. So the point at which the VU is going back is your 0 decibel point, and you can then over bias it by the amount of decibels that it's going back. So that's a bit confusing, but that's how it works. And when you under bias it, of course, then it's also turning back, but that's, you know, towards the other side. So it's like you have a max and then it goes back. So that's how bias works. All right, so let's look at the VU meter of 7. So I'm going up now. It's still a bit wobbly. I have to take a look at that. I think that has to do with the tape transport. Now it's going down again. So the peak, when screwing it backwards right now, so the peak is at, let's say -2, screwing it backwards, now it's going down again. Okay, so forwards and to -5, and then, because that gives us a 3 decibel over bias. Alright, nice. So now I'm also directly going to calibrate the level of left and right. Maybe it's better to do that with 1 kilohertz. So I just checked these two. Woo! Sounds pretty good already, and the balance is not correct and stuff, and there's a little bit too much high frequencies on it. But woo! Sounds woo! Let's do the whole machine. Sorry for the messy video, but we're a few days ahead now. It's fully calibrated. All the channels are like solid. Left and right is perfect on all the channels from an EQing point of view and also from a distortion point of view. So I'm really happy with that. There is a small issue right now with the fact that I'm feeding unbalanced signal into the machine, which practically gives me 6 decibels of loss. That's what I measure right now. I really need those extra 6 decibels in order to drive the machine a bit better. So I'm going to think about what I can do about that. But in general, the machine is in a really good condition. I will make one more video in the future about fixing of channel 1 and 2 on the machine, because that's still an issue. But I'll keep you guys posted on it. Now let's do a quick demo of how it sounds right now. Thing to notice is that I'm feeding the audio from the Neumann console right now, because that one has enough gain. Alright, and that's it for this video. I hope you guys learned something. I actually learned a lot while doing this, while making this video. So that was really interesting, and probably next time I'll do things different. And I'm going to read the comments underneath this video to see if people have any ideas of things that I could do better. Anyway, if you want to support me, you can do that by pledging a bit to my Patreon campaign, which I'm going to link over here. By pledging a bit, you get stuff in return, like early access to videos, answers to your questions, and all that stuff. Another way to support me is by buying a t-shirt with my logo on it. It's linked below. And the last way to support me is by watching more of my videos. You can do that by clicking here. And of course, subscribing. Thanks a lot for watching, keep pushing, and bye bye.